first step is to estimate the difference in size of Kerbin and the Moon. We use the same method as Aristarchus used to measure the ratio between Earth and the Moon by observing a lunar eclipse and attempting to draw a circle that matches the shadow the Earth casts on the Moon. In doing so, we estimate that Kerbin and its moon have a ratio of approximately 3:1.
To find the circumference of Kerbin, we measure the elevation angle of Kerbal from two locations along the same latitude. The distance between these points has been found to be 300 kilometers. The absolute sum of the complementary to the elevation angles is theta. Using the arc length formula, we can find Kerbin's circumference. The first angle we measure is 6.5 degrees, and the second angle we measure is 22 degrees. As mentioned before, we have a 6.5 degree angle and a 22 degree angle. Combined, they're 28.5 degrees. Plugging in 28.5 degrees for theta and 300 kilometers for distance, we get the circumference to be 3,789.5 kilometers. When the moon is in its first quarter, it makes a right angle to Kerbin and Kerbal. We use this fact to make a right triangle, with theta being the angle at Kerbal and phi being the elevation angle of Kerbal. At noon, we observed the moon's elevation angle of 0 degrees.
As it's impossible to target Kerbal, we put two target satellites in its orbit to which we can get an average phi value. The measured elevation angles are nearly indistinguishable, so we used angles of 89.9 and 90 degrees. We calculated an average phi value of 89.95 degrees.
Using trigonometry, we get the tan of theta is equal to the moon's distance over Kerbal's distance. We then found the distance to Kerbal is 1146 times the moon's distance from Kerbin. Next, we have to find the angular size of the moon and Kerbal. As we can see in the solar eclipse, the apparent size of Kerbal and the moon is the same. To find the angular size of the moon, we measured the angles to the leading and trailing edges of the moon. We found their apparent sizes to be 2 degrees.
Similar to on Earth, the existence of solar eclipses verifies that Kerbal distance over moon distance equals Kerbal diameter over moon diameter.
Bringing everything together, we can make similar triangles to find the distance and size of the moon and Kerbal. We know that Kerbin is 3 times larger than the moon, so we can calculate its diameter from Kerbin's circumference. We can now plug in 402 kilometers as a diameter and calculate that its distance to Kerbin is 11,514 kilometers. Finally, we can get the distance and size of Kerbal. We can find the distance to Kerbal by multiplying the distance to the moon by 1146, giving us a distance of 13,194,000 kilometers. Then, using trigonometry, we can solve for the diameter. The tangent of 2 degrees is Kerbal's diameter divided by 13 million kilometers. So then the diameter is calculated to be 460,745 kilometers.